Hey everyone, this is DeFlight with a new video showing off our brand new custom planes. With release of version 2.0, we have completely redone how the custom planes actually work. So you have the ability now to be able to add whatever plane you want with whatever button you want to any of the Skalarki buttons, displays, LEDs, and so forth. So this is going to be an instruction video and a demonstration of how to use that. Without further ado, let's get started. When you first go to your plane activation window, you will now see that you have the custom plane here, and you have the ability to select up to 10 profiles for your custom planes. Now you can have only one, of course. You don't have to have 10. You can have as many as you'd like, up to 10. So this is where you would select which profile you're going to want to use. So when you purchase our custom plane package, you're going to get an activation key, and this is where you will enter it. The custom planes cannot be used without the activation key, and you can also not use the custom planes if you do not have the template, which is what we're going to go over in this video. Now to the right, you will see we also have an enable and disable. Now what this does is when you enable the custom plane, it will override any of the preset plane lists that are built into the software. As you can see, we currently have the fly-by-wire Phoenix PMDG Airbus A310 longitude and CRJ built into the software. Whenever you hit enable, it's then going to override whatever that plane is and allow you to use your custom plane profile. Now furthermore, whenever you use a custom plane, you cannot change or alter any of this without being in the main menu of the simulator. So you can't do this while you're in flight, and you can't do this while you're in the cockpit. So just be aware that you do need to restart the flight anytime you make any changes. Alright, so that's how you use the custom planes. So now let's go through where you put the custom planes and how you actually program them. Okay, so once you activate the custom planes using your license key, you're going to get a new folder called Custom Planes here in the main folder of the software. And this is where you're going to put your custom planes in there. Obviously right now we don't have anything in there, but this is where you're going to put them in order to use them. A thing to understand is this is where you do all of your custom planes. So you do not want to put them in any other folder. They have to be in the custom planes folder within the application in order for this to work properly. So you can't have any shortcuts. You can't have this in another folder somewhere on your computer. So we're going to go through the programming. When you receive your custom planes package, you're going to get a custom plane template. You're also going to get the fly-by-wire template that was made, so that way you can review it and have a better understanding of how this all works. Now you're going to see we have a number of columns here. Your first column is going to be your ID. You're not going to want to alter that in any way. As you add rows, it's going to automatically update your IDs, so you don't need to touch that. Your variable source is what the actual signal, either the SimVar, the SimConnect, event, is going to be sent to the actual simulator, and we're going to go through that in detail when we get to variable source. Your type is what tells you what kind of type the variable source is. Is it a custom? Is it an LVAR, an H event, or a SimConnect? And we're going to go through those three. Your unit is going to tell you what type of unit that you're using for that particular variable, and again we're going to go through that in more detail. Your read or write just tells us if this variable source is a readable value or a writable value. We also have the ability to both read and write. Specific LVARs, for example, are both read and writes. Power type we're going to go through in detail, but what this means is when do you want this button or this LED or this display to actually function. So you can pick when you want the actual LED to work and when you do not want it to work. Same thing with the displays and same thing with the buttons. Your panel is just what your Skalarki panel is. The first 9 here are your power panels, and what this is it tells the entire worksheet here when those particular powers are on. And we're going to go through that when we get to the notes here. Your event type is very important. Your event type is what tells you what type of event this variable source actually is. And again, we're going to go through that. Variable 1 and 2 and min and max we'll go through as we go through the event types. And then we have our notes. Now the notes are very important. Anything with feedback, as you can see on the feedback, will need to have an is on next to it. And that tells the feedback that this particular thing is on. The first 12 lines will not be touched. You will not touch how they function. They will be locked in your version. Now you will be able to put in the variable source and the unit. You're not going to be able to do anything else. So how this works is when main power is on, it's going to use your main power type. When battery power is on, it's going to use your battery power type. And when delayed power is on, which is a third type of power, some planes have a delayed power, such as the Phoenix for the glare shield, you will have delayed power. Now how this works is the main power 1 and 2 are ORs, which means main power 1 or main power 2 is on, then main power is on. Whereas battery is an AND, which means battery power 1 and battery power 2 must be on in order for battery power to work. So for example, if I go to my variable source and I say battery 1, that's my variable source, and let's say I only have one battery, I would want to copy the exact same thing to line 4. That way battery 1 and battery 2 will indicate that they are both on. Delayed uses an OR, so it's delayed power 1 is on, or delayed power 2 is on, will provide the power type of delayed. Enunciator testing. So what this does is if you put in the enunciator test is on, that's going to turn on all of the LEDs and displays on the plane, and you can assign them to 3 different things, the bright or the dim switch of the plane. Power is on is for the RMPs, and that is the power switch on each of those RMPs. This allows you to have functionality for those power switches and be able to indicate when the power is on and when the power is off to those. Again, these are things you're not going to touch very often because this is the main power of the plane, and this is where you're going to enter in the variable sources. Now, as I mentioned, it does come with a fly-by-wire template, and we're going to go through that once we're done going through this template, just so you can see what an actual template that is complete looks like. Alright, so we're going to first start with the notes. You're going to see that LEDs have an LED indication on the right. The brake pressure has an indication on the right. You can see that this is a feedback for the anti-skid switch, and it has an is on. All buttons have a press and a release. And then if you go to some of our switches have an on or an off typically, and of course there are some switches such as the ADIRS that has a switch and it has all the switch states. The notes are going to be something that you do not want to touch. These are something that is keyed into the system that tells what each device or what each button and LED are, so do not touch them. However, you do have the ability in which to add to this list, and you can also delete the list. So for example, if you're not using the VHF call LED, you could just come over here and delete it, and it's not going to make a difference. Same thing goes for, let's say you wanted one of your buttons to do multiple functions. I can come over to my VH1 call button here, and I can add a line, and then if I copy and paste the same exact thing, now whenever I hit this call press button, it's going to do 2 things at once. So that has the ability in which to do that. Now again, you're not going to want to touch the top buttons. Do not add or delete to these buttons up here because they are keyed into the system and your application will crash. Alright, so we're going to undo those 2 changes here. So we're back to how we were. Alright. So that's the notes, and you're going to see there are every single thing that we have in the entire system. Alright, so the next thing we're going to go over is the variable sources, the most important part of this. How this works is anytime you type something in here, it's going to believe that it is a SimConnect event automatically. Now, SimConnect events can be found by going to the notes by hovering over your mouse over type, and you can see the right values. There's the website for the right values, and there's the website for the read values. Once you go to that website, you're going to see that this is a listing of all of the variables that the sim provides through SimConnect. So for example, if I hit circuit pilot heat on, here is the variable number for pilot heat on. It'll also tell you right here the units, as we went over a little bit. And then it will also tell you if you can set it or not, either a write or read value. So for example, let's go ahead and copy and paste the circuit pilot heat on. Now we know that this is a bool, and we know you can't set it, so it's a read value only. So since it's a read value only, we can come over here and we can just type in circuit pilot heat exactly as we copied and pasted it. We know the unit is a bool, so you're just going to type in exactly as it says, bool. We know it's a read value only, and the power type in this case is going to be always, and what that means is it's always on no matter what the power is of the plane. We're going to come to the next portion, which is the variable. Since this is a Boolean value, you don't actually need to adjust any of this. It's automatic for you based on the SimConnect value. So circuit pilot heat on, SimConnect, bool, that's done. Now let's just say that circuit pilot heat on was a writable value. We would just change that to write. And let's say it was both. We can also just set it to a read and a write. So that way we can use it for both purposes. That is how you put in a SimConnect value, as you can see. If we come back to the website and we go to our events, so let's go to the events website. Now just remember, the variables are typically going to be your readable values, where your events are going to be your writable values. So let's find a good one. Let's say anti-ice. Now you're going to notice that anti-ice has a number of different things here. You're going to see that it has an anti-ice set. It's a bool, as we went over earlier. But now this requires an argument, and that's where the variables come in. So if we come over to anti-ice set, and we're going to copy and paste this to our Excel spreadsheet. So we copied and pasted our anti-ice set. Now we're going to go and find anti-ice. So if we go to panel anti-ice, we have a wing press and a wing release. So we're going to come over here and we are going to put in anti-ice set. Now we know it's a bool because it told us it's a bool. It's a writable event. Now let's just say we don't want the wing button to work unless the battery is on. So we can set it right here. Now this is a button, but it could be something different, but in this case it's going to be a button. And because this requires arguments, we're going to need to put in the arguments. So for example, in this case, anti-ice set has an argument of 0 and 1. Now what this means is when I press anti-ice set, it's going to look at the anti-ice system, and it's going to look at number 0. And then since it's a press, I want it to set it, which means 1 or on. Now I'm going to take this, I'm going to then just copy and paste it below, and now the release is going to do the opposite. But it's still going to use that first variable argument. Now let's go back to the website, and you can see that anti-ice requires an engine number as its first argument. Well, we're doing wing, so it might not require the engine. So that's where you go to engine control select, and it's going to tell you which number is the engine that you're going to be working with. And that's where you're going to use the number or the first argument as we discussed, and then the second argument is going to be 1 if it's on. Now you'll notice that they also give us some other ones which do not require a second argument, because these already have the engine already selected. So what we could do here is copy and paste. Now since this already has engine 1 in the variable, we don't need to assign it a argument for the engine. So we know it's a bool again because it says bool in the units. But this time, instead of giving it 2 variables, we're just going to give it the first variable. As you can see, now we have engine set 1 is for our press. We're going to copy and paste. And you'll see I have 2 engine 1 presses here. And then I'm going to go to release, and I'm going to give that a 0. So now anytime I push this, it's a button, and it's going to send 0. And when engine 1 press is sent, it's going to be a 1. So that is how you put in the variable source for a SimConnect and give it a variable. Okay, so let's say we were going to now use LVARs. And a good example is the 5-by-wire uses a lot of LVARs. And to get this information, you need to use a program such as spad.next, or you can go online and you can usually find these variable numbers. So let's go to Fly-by-Wire's SDK online and get a variable from that website. If you go to the Fly-by-Wire website and you go to the Developer API, under Developer API, they have a custom LVARs. If you click on that, that's going to bring you to the local SimVars. Now we're working with the anti-ice, so we're going to go to pneumatic, which is what they have it listed under, and we're going to look for our LVARs as we discussed earlier. So this time we're going to be doing the wing anti-ice. So if we come down here, you're going to see we have an indicator whether the anti-ice is on. We have an indicator of whether the anti-ice is fault. Now again, this is an example, but all you need to do now is click on this, and this will tell us when the anti-ice system is on for the wing. So we're going to come back to our spreadsheet, and now we know when the wing light is going to be on, and here's our LED. So we're going to copy and paste it, but it's saying it's still a SimConnect. Now in order to use LVARs using this, you're going to put an L followed by a colon. And I would recommend that you keep everything capitalized on the variable source, because that is how they have it on their system. Also, you'll notice they have a number of underscores. So you want to keep it exactly the way that they have it. Now it is switched to an LVAR. Now all LVARs are going to require a unit. Now all LVARs are going to require a unit. Now you saw in their documentation that they have told us it is a bool. So we can hit bool. Now let's just say we do not want the wing light to come on unless we are on our battery. That means that this LED will never turn on unless the battery is on. Here is where it gets a little tricky. Some LVARs require a number, such as on the fly-by-wire, their switching on the ECAM requires a number 1 through 12. Now most of the LEDs that are supplied by fly-by-wire and most other planes do not require a variable. Now let's say that this anti-ice system had 3 different states. It had a fault state, it had, an on state, and it had an off state, and they all had different digits. That's where you would put in the variable to indicate which number is going to be your anti-ice system on number. So that is how you use an LVAR. Now some planes will actually have what's called an HTML event, or H event for short. Not a lot of planes have them, but fly-by-wire uses H events. There's not really an easy source to get them other than using maybe spad.next or some type of variable scanner. But let's just say that this wing light was an H event. Instead of L, you would put an H in front of it, and now it becomes an H event. Most of all H events do not have a unit, and they also do not have variables. There are a few that do. So for most H events, this is what it's going to look like. And that it's going to indicate that the H event has been triggered. So that is how we enter our variable sources, our types, and our units, and a little bit of how you use variables. So now let's go back up to the top and go over the event types in more detail. We have a number of event types, and if you click on one of the boxes, you'll be able to see all of them. We're going to go through them one at a time. For all of this information, you can always put the hovering over any of the top pieces here, and it'll give you a little bit of detail on how to use these. Also, if you click on unit, this will be able to tell you where to get the units, where to get the variables, and so forth. It's very helpful. We're going to start with button. Button was the most simple one that we've already done. And what button is it's going to send a 1 when it's pressed and a 0 when it's not pressed. In most cases, most buttons on most of the planes are just going to be single presses, and that's it, such as the autopilot buttons on most planes. So for those, you're going to use a button. We went through kind of what variable 1 and 2 do. You will need to indicate a variable if there are arguments assigned to that variable source. The next one is going to be a switch. A switch is going to send whatever is in variable 1 or 2. So what you're going to want to do when you use a switch is you must indicate its variable. So on the fly-by-wire, for example, they have a number of three-way switches. And those three-way switches aren't going to be your standard 1 and 0, 1 being on and 0 being off. They might be auto is 3 and switch is 1. I mean, there's a number of different combinations, and that's where the switch is used. So for example, we could put a 2 here. That would indicate that this line here is going to be a switch, and it's going to send out the value of 2. The next one is going to be your axis. Axis is pretty simple. Your most of your axis are going to be levers and such, and all you need to do here is it's going to use your minimum and maximum calibration value, and you're going to put in a minimum value. So in most cases, it's going to be negative 1630 and positive 16380 for most of the axes, but you know, there's axes that might go a minimum of negative 50 and a positive 400. This is where you have the ability to set that to whatever you'd like, and that is what an axis will do. And every axis is going to need a min and max, so you have to put something in these boxes. The next one's a display. Display is pretty self-explanatory. There's going to be no variables with a display. It's just a strict display. It's going to be sending it right to the display. Next one, LED, we kind of already went over. An LED, you can put a variable here if the LED is not your typical 1 being on and 0 being off. Let's say the LED that's on is a 5, then that's when the LED is going to be on. The LED will be on when it's 5 and off when it's not 5. Okay, so the next one is feedback. Feedback's going to be tied to what we have with a toggle. And we're going to go through that here in a bit once we get to toggle. Increment and decrement are pretty easy to understand. It's going to increment the value or decrement the value based on whatever the variable is in number 1. So for example, if I want to decrement by 1, I'd put a -1 here. For all increment and decrements, you're going to need to put a range. So for example, this button or this line here is now going to increment or decrement, in this case decrement by -1 all the way down to -50, and that is when it's going to stop. If I wanted to then put an increment, I could put a 1 here and do the same range, and now we're able to increment and decrement by 1 through this range. Next one is going to be direct. Direct is pretty self-explanatory. What direct does is it sends exactly what Skalarki sends. So for example, if Skalarki's button sends a 1, it's going to send a 1. If Skalarki's button sends a 0, it's going to send a 0. Most, if not all, of Skalarki products, with the exception of axes, send a 1 or 0. In most cases, you do not want to use direct for an axis because those numbers are not going to be the same as the numbers within the sim, and that's why you need to scale them using an axis, but that is what direct does. Another one we have is encoder. Now when you hit encoder, you're not going to need to use a variable 1, 2, or min max. What an encoder does is it strictly sends a increment of 1 and a decrement of -1 when it's an encoder. So you'll use these sometimes for encoders that require you to add or subtract a number. In most cases, like in the fly-by-wire, there's an actual variable to increment, and therefore you use a button. And we're going to go through that when we show off the fly-by-wire template that is being used. And then our last one is toggle. Now what toggle does is it uses the feedback. So for example, let's go down to a break, and here we have a toggle. Okay. Now what toggle does is this terrain press button here is going to use its feedback from the read-write value. Okay, so when you toggle this, it's going to say, okay, is this particular event on or off, and do the opposite. It also can be used with a separate line that has an is on. And again, we're going to demonstrate this a little more in detail when we get to the fly-by-wire. But a toggle uses feedback and therefore requires feedback or a read-write value in order to function, and it does essentially the opposite of what you want it to do. So that is what a toggle does. All right, so that's pretty much about it with using this. Once you are done, this is the most important part. You're going to need to come up to File, Save As, and you must save it as a comma-separated value. Okay. Another thing that you must do is all custom templates must have capital custom and then the number that you want to assign them to, and that's the profile that we talked about earlier. So once we have saved it, we're going to then put it in the custom planes folder, and that's it. That is how you use a custom plane. So here is the fly-by-wire Excel that you're also going to get with the package. And this is more of going to be used for assistance in understanding how this all works. Of course you can use this, edit it, and then put it in as a custom plane, and then you're going to have the fly-by-wire working just like you would have it as it is right now. So a couple things I'm just going to show you real quick is you'll notice the LS press is a toggle. It uses its read-write value. It's also an LVAR, so it can not only read the current state of the landing system, but it also is how you send the information from the button. This is where you would use the read-write because you need to know when it's 0 and when it's 1, and that's where the toggle comes in. Now if we go to the A brake and we go to our anti-skid, you will see that the anti-skid tells you when the anti-skid brakes are active. And the reason we need to know this, and you can see it's a feedback and it has an is on next to it. It is a switch, but it's anti-skid brakes toggle. So how would it know when to send 1 or 0 based on or off? That's when you would add this feedback line. So anytime you add this feedback line here and you put an is on after it, it then will take any of the presses or any of the switches and use that feedback that is above here to tell it when it's on and off. And that is how that works. If it's a read-write, it uses the same signal on the same line. So that is essentially how that works. So that's about it. That's how you use the custom planes. In the future, we're hoping that we can have an actual application that will do this for you. However, that's a significantly big undertaking. So for the time being, this is how you can make custom planes with our software. So hopefully this video helped you. And of course, if you have any questions about this, you can always contact us and we'll try to assist you. If you do need us to make custom planes, we do offer that service as well. So you can contact us as well and we can give you a quote on how to do so. So thank you for watching, and again, thank you for the support, and I hope you have a wonderful day.